Question number 22. Okay, so shown here is a spectrum of an atom with wavelength increasing. Okay, let me call this wavelength as lambda 1 here. And let me say 1, 2, 3, 4, 5, 6. This is lambda 6 here. Okay, which of the following energy levels can produce this spectrum? Okay, so there are levels given here. Which is the easiest one to look into? This is the easiest one. Now you see, let me assign some numbers. This is 1, this is 2, this is 3, this is 4. Okay, equidistant over here. So what we can do is, if an electron jumps from here to here, what is the energy difference? 1 electron volt. Here to here, 1 electron volt. Here to here, 1 electron volt. Which means each of these lines will produce the same frequency, same wavelength. Which means you will have 3 lines which are overlapping on top of it. That means in the spectrum there should be one line which is having 3 lines or more thicker. Do we have anything like that? We don't have anything like this. So therefore this is incorrect, right? So we need to reason something like this only. Then next what we do is, now let us look at the 3 are now present here. Now what is the similarity between this and this? There are 2 lines here. Similarity between this and this, there are 2 lines over here. Okay, so now what we do is, let us understand what's happening here. If an electron jumps from here, it jumps from here, this will give you, this is very less. Okay, now since I have given you 1 here, so 1 here, this could be, this is 2, this could be 2.5. Let us give some values. Only then it's easy for us to solve. This could be 3.5, this is 4. Now 4 to 3.5, if it jumps, then lambda 1 will be equal to hc divided by delta E, which should be equal to 0.5. I'm not going to find out what is the value. Then if it jumps from here to here, then what will be the value? It will be 4 to 2.5, which will be lambda 2 should be equal to hc divided by 1.5. Let us estimate this also. This will be lambda 3. Lambda 3 would be equal to hc divided by 4 minus 1, which is 3 electron volt. Okay, so I get like this over here. Then in a similar way, now what all other transitions are possible? Let us look at here. If an electron is here and it jumps here, 3.5 to 1 will be lambda 4 should be equal to hc divided by 3.5 minus 1 is 2.5. Now we have a pattern here. Look at this. This is 3, this is 2.5. These 2 lines should be closely related. Where is this seen? So here 3, that means energy is larger, wavelength should be smaller. This should correspond to these 2 lines. Okay. So somewhere we are able to account these 2 lines using this diagram. Which diagram? This diagram. But we are not able to account this one here. So if I want to account here, maybe I can help out, get help from here, right? So in such cases, for example, what can happen here? So it can jump from here. One electron can jump from here to here. You get, this is 4, this is 1, 4 minus 1 will be 3 over here, hc by 3 here. And if an electron jumps from here to here, what do you get? You get hc divided by 2.5. So which might correspond to something like this once again. So somewhere energy differences are larger. So if I combine this energy level with this energy level, what is that I get? If I combine these two, I get this one, and this doublet will be with this one here. So somewhere I feel that A should be the right answer. Okay, now let us verify if you want whether A is right or wrong. Okay, so then we can discard these two. Now if an electron is here, it will jump from here to here. What is the value here? So from here to here if it jumps, and from here to here if it jumps. This is your 4, this was your 1.5, difference was 2.5. So your wavelength was hc by 2.5. Okay, if it jumps from 4 to 1 here, you get hc by 3 here. In a similar way, if it jumps from here to here, what is the answer you get? This should be 3.5 and this is 1.5, which should be 2. Okay, so hc by 2. And then if it jumps from one more from here to here, what do we get? This is 3.5 and this is 1, which should be hc by 2.5. Somewhere you see 2 and 2.5 are closely related, 2.5 and 3 are closely related. So therefore you are getting a doublet here, you are getting a doublet here. So which will mimic these 2 positions. As a result of it, A is the right answer. C and D can be discarded. Okay.